forever. What about annuities with it's just a fixed annuity, right? We're just moving forward and the payment stream is equal. This is really the more traditional kind of an annuity. It's an equal payment for a finite period of time. Now the formulas, you can see, start to get a little bit on the ugly side. So this is why using the spreadsheet is just much simpler to use in making these calculations. So here you have, you're a lucky winner of a $30 million state lottery. You can take your prize money in 30 payments of $1 million, or you can take $15 million today. If you could invest at 8%, which option should you take? Well, we can answer this a couple of ways. This just seems to be the simplest one is, if you took the 30 payments of $1 million and you started that today, N equals annuity due, right? And you could get 8% interest. What is the value of that in today's money? Well, of course, you can see here that the present value of that annuity is $12.1 million. So which would you rather have? $12.1 million or $15 million? Hopefully $15 million you know is the correct answer. So now $15 million is in today's money. The present value of this annuity is in today's money. So we can make comparisons to those amounts. We could ask the same question just another way. If you took the $15 million and invested it for 30 years at 8%, how much could you pull out beginning at this year? You could pull out $1.2 million a year. Well, the lottery commission was offering you $1 million a year, or you could get $1.2 million on your own. Which would you rather have? Hopefully the answer is obvious. What about the future value of an annuity? And again, you can see the mounting complexity of some of these math questions as we move forward. You're 35 years old and we've decided we want to plan seriously for our retirement. At the end of each year until 65, we're going to save $10,000 in an account. If the account earns 10%, how much will I have when I get to retirement? Again, the interest rate is 10%. The time frame is 30 years, 35 years. 65 minus 35 is 30 years. If the payments are once per year, $10,000. It's a negative amount. And again, we're going to do this at the end of each year, so we need to make sure this ordinary annuity says yes. This amount will be worth $1.64 million when I get to retirement at age 65. What about growing value? Sometimes we understand that the cash flows, we want them to ultimately grow. So how can we find the present value of growing annuities? Well, we can do this a couple of ways, right? Here we have just a perpetuity question we asked a little bit earlier, right? The value, you needed $375,000 to invest. But if we're worried about inflation, maybe we want to incorporate that into the problem. So in the spreadsheet, there is a place to put the growth of a perpetuity. We want this to grow by 4% per year. So in this case, we're going to have to invest $780,000 a year in order to pay this $30,000 a year. Again, that's assuming inflation. So without inflation, we need $375. With inflation, we need $780. This is a perpetuity, so it's also going to grow to infinity. Again, growing annuities. What's the present value of a growing annuity itself? Again, not a perpetuity, but one that has a finite time frame. Again, we can do the exact same thing. We want to retire with an income stream of $100,000. Our challenge is we expect to live for 25 years. We can get 8%, and we're worried about inflation. So the questions are, how much do I need to invest so that I can get this cash flow stream? And then the second question is, If I'm worried about inflation, how much has to be invested to take care of inflation? Interest rate's 8%, time in years is 25. The payment, $100,000 is what I'm going to receive. It's a positive amount. And the growth of an annuity is our inflation rate of 3.2%. So the present value of an annuity, if I don't care about inflation, I need $1 million, $1,067,000. But if I want to cover for inflation, the present value of a growing annuity, I actually need to invest $1.4 million. Again, an extra $300 and some thousand to cover for the impact of inflation over this 25 years. What about non-annual cash flows? Right? What happens if we change the compounding frequency? Right? If you want to invest $1,000 for 6 years, and you've been able to earn 8% investment, how much will we have at the end of 6 years if you calculate interest just once a year? Here's 6 years. The compounding frequency is the variable we're changing here. At the end of 6 years, you'd have $1,586. Now, what I'd like you to note is the effective interest rate is the actual interest rate you earn. It says $8,000. But what if you invest the same amount of money, but you can get a compounding frequency of 12 times per year? So every month we're going to calculate interest. The actual end amount will be $1,613. And since that's more, we obviously have a higher rate of return. The effective interest rate is 8.3%. What about solving for the cash payments themselves? Right? How do you solve for this payment piece? Again, in this case, it's sort of a loan question, obviously, but we want to talk about how you solve for that. It's much easier to use a spreadsheet. In this case, I've actually provided a worksheet called loan analysis. Your company wants to buy this sequencer for $500,000. You're going to put 20% down, and I'm willing to finance the rest for a 48-month loan. Interest rate is 0.5% per month. Now, this particular spreadsheet doesn't break down by months. It allows us to do that calculation within the formula. So we need to input the annual interest rate is 0.5% times 12, so that's 6%. The payment per year, we're making 12 payments per year, 4 years, and of course it's 80% of the $500,000 or $400,000. So our payment would be $9,394.01. If you paid all the payments on time, you'd make $450,000 odd dollars in payments, and $50,912 would be interest. We can dissect those things into what's referred to as an amortization schedule. You just scroll over in the spreadsheet and you'll come to this table, but it breaks down the payments into the interest and the principal reduction for each payment and reflects the declining balance as we're making our payments. In some situations, again, I know the present value, I know the cash flows, I'd like to know what the rate of return is. So the terminology or the term we use is something called the internal rate of return. It's not that relevant that you understand this point, but it's the interest rate that ultimately sets net present value to zero. I prefer to talk about this is if you invest the money and if you actually get the cash flows, it's the rate of return on that invested money. So we have this idea, somebody's going to fund our business. They're going to give us $1 million, and then we're going to make payments of $125,000 at the end of each year for 30 years. So what's the internal return? What's the return on this payment stream? So again, this company's going to fund us, going to give us $1 million, 8%, 30 years, and we're going to pay them $125,000 to pay off essentially the investment. What interest are they going to earn? Again, the $125,000 is what they're going to receive. The million is what they paid us. So that rate of return on their investment is essentially 12.09%. So we can calculate for that rate of return. In 1954, I bought a Mickey Mantle baseball card 10 years ago, obviously for $200. It's currently worth $975. What's the return on this investment? Future value, it's currently worth $975. It started out as a $200 investment. You leave the interest rate blank. Time in years is 10. We will solve over here for 17.16% is the rate of return on this investment. How about the number of periods it will take? The most common question, about the only really good question, is how long does it take for my money to grow? In this case, we want to know how long it takes for my money to double. So if you can earn 10% on your money, how long does it take? Well, in the spreadsheet, I could put in a negative $1. If a dollar doubles, it doubles to $2. Interest rate's 10%, and you delete the time in years, compound frequency 1. The time is 7.27 years. There's something called the rule of 72. It's an approximate answer. You take the interest, divide it into 72. In this case, it takes approximately 7.2 years for your money to double. You currently earn $70,000 a year, and you've been able to save $20,000 in an investment account. You're going to retire in 30 years at age 60. Inflation's 3.3%. How much would you need to earn in income when you get to retirement to maintain your current lifestyle? Well, I currently make $70,000. The inflation rate's 3.3%. Time frame here we're looking is 30 years from now. So when I get to retirement, I'm going to need to make $185,399 to live on during retirement. So now I'm in retirement. It says, look, if I live to be 85, how much am I going to need in my pension fund at age 60 if I can earn 7.5%? So now I'm going from 60 to 85. That's 25 years. My investment return is 7.5%, and I would like to get this $185,399. So the present value of that, I need $2.066 million in my retirement account to get $185,000 a year. What if I'm worried about inflation? We mentioned that a little bit earlier. If you put in here growth of an annuity, 3.3%, the actual present value I need is actually $2.78 million. So I need almost another $700,000 to cover inflation during my retirement time. So how much do I need to invest each month in my retirement plans to get that desired retirement? So if we go back, I want to get $2.066 million is what I want. I currently have $20,000 invested. I can get 12% of my money. It's going to be 30 years. And the compound frequency is 12. So this question, all right, is without inflation, I would need to make payments of $385,000 a month to cover my retirement plans moving forward. Now, what if I wanted to do the thing with inflation? If I do it with inflation, I need to put this $2.78 million, same numbers other than the future value. Now I need to be able to invest $590 a month. So in the end, I have to ask some questions. So what's my monthly salary? Well, I was making $70,000. That's $58.33 a month. What percentage of my paycheck is needed to cover inflation? The payments of $590 into $58.33 is I need 10.11%. The question is, can I afford $590 a month? Does the company match any of my efforts? Right? If the company's going to match, then I don't need $590. I need maybe half of that. So we can answer a lot of retirement questions based on the last several slides. So that's the time value of money.